Greetings. We're talking about digital 3D today, which is a super fun, cool, creative space to be in. If you're new to digital 3D, that's totally great. Many people are. It's a lot of fun. It's got some vocabulary and some concepts involved. We'll go through some of those today. And in general, it's not that bad. It's pretty fun, but it just takes a little bit of conceptual learning to get started, and then you're off to the races. But first, we're going to talk about 2D. This is Photoshop. Hello, old friend. And in Photoshop, right, or any other application like Affinity, Designer, Illustrator, whatever, you have width and you have height, right? And width is your X, and height is your Y. And that's not really articulated that much in many 2D applications, but in 3D world, we think of width as our X and height as our Y. And a standard computer width, right, is maybe 1920 wide by 1080 pixels high, or our X is 1920 wide and our Y is 1080 high. If you have a different computer to monitor resolution, it's different numbers, but roughly the same concept, right? Okay, so back to 3D. In 3D, we have some kind of concepts. In something like Photoshop or Illustrator, you have a kind of blank workspace, right? And that blank workspace is the world that you use to create stuff. And in 3D, we have a world also. It's the space that we use to hold everything. And inside this world, and that's a 3D world, unlike Illustrator or Photoshop, it's a 3D world. You can think of it like a sphere or something, but really we call it a world. It's an easy word to hold in our head. And then we also have objects and we have cameras. And objects is just the stuff we create in the world. Cubes, squares, anime characters, whatever it is. And then cameras are a way that we see the objects and the world. So without a camera, there's no way to see into the world. So we create these kind of virtual or fake cameras in our 3D world, and through that camera, we see the world, and we on a 2D plane called our monitor, and we can share screenshots and that kind of thing. But all that work is done through this thing called a camera. And yes, a world is pretty empty when you start. Not much really going on. You'll often see a world represented as this kind of grid shape that's kind of extending off into infinity. And on that grid, you'll often see some lines. And we call this sort of whole thing like the world orientation. And those lines are meant to describe which way is up, which way is left and right, the width, which way is the depth or the Y. It's a little bit like hard to remember. Like often you're just seeing it without the letters. There's a red line, there's a blue line, there's a green line, and you're like, well, what is all this? And so I have a little mnemonic that I use to remember X is red, Y is green, and Z is blue. And I think of the Jackson 5s, A, B, C, easy as 1, 2, 3. I use X, Y, Z, easy as RGB. And so if you ever can't remember, like, I'm looking at this green line, but what axis is that? Oh, it's the Y, because X, Y, Z, easy as RGB. And in Blender, Z, the blue line, is up and down, right? So a ceiling fan up in the sky, that is up the Z-axis to the ceiling of the room, where something like a hardwood floor would be down the Z-axis to the floor. X might be the width of something, the width of your desk, the width of the room. And then Y is our depth. So that's the depth maybe of our desk going back to a wall. That's the number of steps it might take to get to a door, something like that. And now here's where it's easy to sort of have a head exploding moment. And you might say to yourself when we tackle this slide, like, my head is exploding, but we'll get through it. So it gets tricky. every application is kind of different. So Blender says that Z is going to be up and down, but our friends who use Cinema 4D, for them Y is up and down. It's like, okay. And so it gets complicated. But really the thing to remember, often you just have to remember what your application is doing, but it's good to know that everybody's is different, and so you can't always just assume that Z is up and down, Y is your depth, and X is your width. Um, but it's also hard to hold it all in your head. So in some ways, it's good to just remember, like, okay, the application I'm using, Blender is the one I use. It's one I'll make all these videos with. Z is our up and down, X is our width, and Y is our depth. And so there's this rule called the hand rule that makes it easy for us to think about 3D space using our fingers and our hand. And the easiest way I've ever thought about this is, and I've actually really struggled to find a good explanation of this online, which is one of the reasons I wanted to post this video in the first place, is always imagine X is your thumb, Y is your index finger, and Z is your middle finger. No matter what application you're using, doesn't matter, Unity, Cinema 4D, Blender, whatever, your thumb is X, Y is your index finger, and Z is your middle finger. And now, here's where we kind of twist our hand into a shape that kind of looks like the edge of a cube, right? It's like if all the edges of the cube were coming together sort of in the middle of our palm. You could do this, and you could kind of move this imaginary cube around in space. And you'll hear applications referred to as things like right-handed Z up, or left-handed Z up, or left-handed Y up. And you're like, what is that? I don't even know what that means. And it's the thing that really helps keep it solid in my brain is always remember Z is blue, Y is my middle, and Z is blue, and it's my middle finger. Y is my index finger, and it's green, and X is my thumb, and it's red. And so if they say Blender is right-handed Z up, I take my right hand, right? I make the cubey shape, and I point Z up. So here's right hand, Z is up, right? This is Z. And what you really have to do is this is a tough one. You have to kind of twist your arm around so that X is pointing off in the diagonal direction to your right, and Y positive is pointing off in the positive direction to your right, like this. I know it's weird, but it works. And then, if you think about Blender, you're always like, okay, because in the world space you can kind of twist around, and it's maybe hard to track where you are. So if you always just sort of think about this hand rule, you can kind of overlay it onto what you're seeing on the screen, and always remember what your Z-axis is, your Y-axis is, and your X-axis is. And this, again, is true. Some applications do it on the left hand, some do it on the right. You can use both just the same as long as you remember what letter goes on which finger. Cinema 4D, this application is called a left-handed Y-up application. So you take your left hand, you take the Y, which is your pointy finger, you point it up, and again you make this cube shape, right, with your finger, and you say Y up. Cinema 4D is left-handed Y up. And now we know that Z positive is going that direction, Z negative is going that direction, X positive is going that direction, X negative is going that direction. And we know if we need to move something along the Z-axis in the positive direction, it's going to end up over here somewhere, right? And if we need to go up, we need to use the Y to get it up higher. And many applications are different, right? 3D Studio Max and Blender are right-handed Z up, OpenGL, ARCore, and ARKit. Those are augmented reality platforms supported by Google and Apple respectively, are right-handed Y up. Unreal Engine is left-handed Z up. Unity 3D is left-handed Y up. And it's because all these applications, they just had their reasons, right? But here we are. Everybody does a kind of different thing. And this is why kind of the hand rule is good, because you're often presented with something different. So again, Blender, right-handed Z up, like this. ARCore, for example, again, right-handed Y up, right? And that's different than Cinema 4D, which was left-handed Y up. And you might be asking yourself, why does this matter? Does the world hate designers? And the answer is no, it's just a giant mess. And you may kind of think, I'm never going to remember this, but there is one good reason, and really two good reasons to remember this. Reason number one, you're now a member of an elite group. We have NASA astronauts, for instance, Colonel Benjamin Alvin Drew, has logged more than 600 hours on the space station. We have Dr. Sylvia Earle, oceanographer, who's led more than 100 expeditions, logged over 7,000 hours underwater. And we have ourselves, right? We're new digital 3D enthusiasts, and we've installed Blender. We're getting there. And the question is, for this elite group that we're now a member of, is how do we conquer spatial disorientation, right? Astronauts have a tether, so if they get hung up in space, they can use the tether that connects them and kind of find their way back to the spacecraft. Or, alternately, maybe they need to understand what are they upside down or are they right side up? And the best way to kind of think about that is to look at the Earth, right? An astronaut can look at the Earth and say, like, well, is that the North Pole up there that I see at the top? If it is, then I'm upright. But if Africa, the continent, looks upside down, I'm upside down. And so, and astronauts have a word for that. It's called the Earth-centered inertial coordinate system. It's a fancy set of words, but really it's about using the Earth as a reference point for yourself to understand if you're upside down or not. Oceanographers, divers, have bubbles, right? Bubbles are always going to rise to the top, and if you look at the bubbles, you can see which way is up. We, in Blender land and in Digital 3D land, have, again, these viewport axes. And in the case like an oceanographer, we have this z-axis to tell us that z is up. Also, we need to use the positions of the red and the green to kind of understand which way is up as well, because z could also be down. And we'll talk about that. The second reason is interoperability, right? We don't really create in Digital 3D all-in-one application. We're often making a thing in Blender and then importing it into Unity so it can be used in a game or a VR experience. We could do something in Blender and then we could take it into 3ds Max, or we could take it from 3ds Max, we could go into Blender. So there's a lot of importing and exporting that happens. And often what will happen is you'll import something and it will look funny. It'll look upside down or backwards. And here's an example of that, right? This teapot, it's called the Utah teapot. It has a whole funny kind of legacy in Digital 3D world. Was made in 3D Studio Max, and it's a right-handed Z-up application. So you can see it's right-handed, Z-up, Z is up, Y is that way, X is that way. And then it was imported into Unity, which is left-handed Y-up, like this. And so because of that, now your teapot is on its side, and you're like, wait a minute, why is my teapot sideways? And so you have to be correcting for these orientation problems a lot. And you get over it, you get used to it, it's something to get familiar with, but it's a really nice thing to keep in mind as you're learning about 3D applications and you're first getting started, because it is actually quite easy to kind of get disoriented. And if you can figure out ways to keep yourself like head pointing up, feet pointed down, booty pointed down, then you're good. So just a reminder, thumbs are X, index fingers are Y, middle fingers are Z. And in Blender, we are right-handed Z up. That's it. Hope that was useful. I have really struggled to find a video that I thought explained this well. I hope I did my best. I hope it seems about right. So let me know if you have any thoughts or feedback or any confusion. Thanks.